In this lesson, we'll see how Nginx makes it easy to configure a simple yet robust load balancer. Now, first off, let's understand what exactly a load balancer is. In short, a load balancer should achieve two main objectives. One, the ability to distribute requests to multiple servers, thus reducing the load on those individual servers. And secondly, to provide redundancy, meaning when one or more of our load balanced servers fail for whichever reason, the load balancer needs to recognize that and redirect requests to any of the remaining available servers. When I say distribute or redirect, of course I mean proxy. So again, using Nginx as a reverse proxy, and in doing so, keeping the load balancing itself as transparent as possible. Taking this into account, the first requirement for us to test this then is going to be having multiple servers to load balance using our Nginx server or load balancer. To do this, I'll use some PHP servers again, and this time I'll simply have them each return an identifying plain text message. So I'll create these response files, echo PHP server 1 being our first PHP server, write that to a file called S1. No need for an extension here, the PHP server doesn't care about the input file type. Another called server 2, S2, and server 3, file name S3. I'll list the contents of this directory where we see those files, and when we check the contents of S1, we see that string, PHP server 1. So start the first PHP server, PHP sflag, localhost, and this time I'll have it listen on port 10,001, only to have it match the server name we're returning. I'll create another terminal window and start the second server, port 10,002 this time, with the S2 file. And finally our third server on port 10,003 with S3. Test the first one. Works. Second server on port 10,002 works. And the third, PHP server 3, so that works. Right, we now have 3 servers running, and we can easily identify which one we've been proxied to by those responses. Of course, in a real-world example, these servers would much more likely be serving the exact same data, given the same requests, but we'll have to distinguish them in order to test our load balancer. I'll start fresh by creating a new Nginx configuration file. Call this one loadbalancer.conf. Open that new file in the editor and start with an events block. HTTP, listening on 8888 again, and a root location block. This load balancer simply accepting everything and proxying it then. Before setting up our load balancing with our 3 PHP servers, let's test this with one of them. I'll use that first one, so localhost port 10,001. Save and start Nginx with the absolute path to that load balancer configuration file. Curl our Nginx server, and we get the response from PHP server 1 as expected. Right, now to monitor the load balancing, I'm going to issue these curl commands to the Nginx server using a simple while loop on the command line. This will just allow us to monitor subsequent requests without having to run them individually. Say while sleep for 0.5 or half a second, do curl http localhost 8888. Done. So basically we're creating a loop which sleeps for half a second on every iteration and then performs the curl command on our Nginx load balancer. Feel free to run these manually or in any other way you prefer. This is just a quick way using what we have here. I'll run that and we get that PHP server 1 response every half a second, as we're only proxying to that first server at the moment. Let's implement the actual load balancing now. First, we have to create what's called an upstream. This is a context or block in Nginx that groups several servers with the ability to add some options to the upstream. think of it as a named collection of servers that share some or other commonality, in most cases being that they serve the same content. This gets defined in our HTTP context by saying upstream, give it a name. I'll call this one php_servers. And inside this block, define the individual servers by saying server with the value being the host name and port of the server, like so. Add the remaining two PHP servers, 10,002 and 10,003. And now to proxy this location's requests to the upstream, say proxy pass, so a standard reverse proxy directive, HTTP php_servers, that upstream pointing to our PHP servers. Reload the configuration file, run that loop again, curling our Nginx load balancer, and this time we see a near perfectly distributed sequence of responses from our PHP servers. So Nginx is balancing our requests by sending them to each PHP server in turn. This default behavior is referred to as round robin, meaning to simply send the next request to the next server in the upstream. We had a slight variance here for whichever reason, but when I slow this down to 1 second per request, we see a perfect round robin distribution. Of course, the second purpose of a load balancer is to provide us with some redundancy. We can test this by killing one or two of our PHP servers whilst the requests are going out. I'll clear this to make some space. Start again with 1 second. Kill server 1. We see requests continue seamlessly with server 2 and 3. And when I kill server 2 also, we see only server 3 responding. Start server 2 back up. It returns in the requests, and server 1, and we're back to an even distribution of requests between all three of our upstream servers. So again, an easy, robust load balancer in only a few lines of configuration code. In the next lesson, we'll take a look at some different variants of load balancing.